Hello, everybody, and a warm welcome. This is the introduction and overview session of the certificate programs in Python for Algorithmic Trading and Computational Finance. My name is Yves. I'm founder and CEO of the Python Quants, and I will also be your program director. It's always pretty exciting to get started with a new cohort in our programs. We have been growing the program over the years. We have added new topics, among others, AI in finance, to name just one class. And there is more to come that we're going to add. And today's session is meant to provide indeed an introduction, also to whet your appetite for what is on the schedule, basically for the next 12 weeks at least, and then also for the practice phase that comes thereafter, and also to show you quite a few examples, not to teach the topics, but to show you a few, from my point of view, interesting examples that give you a feeling for what to expect in the program. I'm now going through my slide deck. We'll start with a little overview, then enter the introduction, and after a few minutes, we should then already get started with the topics themselves. The agenda has quite a few points. Not all are longer. I've planned for a few case studies and demos. This will be at the core part. The rest is meant to provide you an overview of what to expect. Again, we will have time to go through all the elements in detail and the case studies and demos part here, number 12. This is where we dive into a couple of topics. Again, not meant to be like an instruction, just meant to show you a few things. We will now go step by step through what you see here on the agenda. First, quick introduction. Most of you know about the Python Quants, what we do. It's all centered around Python for finance, and around this topic we do quite a few things. We provide services to financial institutions. We run different events like boot camps. We organize meetups, for example. We do on and offline training. We run our Python Quant platform. We have open sourced a bunch of packages. I have written a few books. And of course, here in the certificate program, the goal is the certification, which is done in cooperation with university. A German university. The page dpq.io provides many more links and deeper resources. So if you're interested, get a deeper look into what we have been doing, feel free to visit the page. The second company that we run, which is closely related topic-wise to what we do, is the AI machine. So there we are building the trading platform, which allows the standardized deployment of AI-powered strategies. Of course, all Python-centered in that sense. And currently, I can say I'm doing the session today from India, where I'm with the team for a little bit more than a week. And we're currently working intensively on the platform, with a goal to go live pretty much soon. Pretty interesting. I like to say that this is our walk the talk. So I've been given that many talks about what one can do there. This is now what we do, and you will see also a few demos over the course of the program in this regard. If you're interested in the quick summary, here's a link to the one-pager that was recently published. It's just a quick reminder of what we have been doing or what you can expect actually during the program. It is about the Algo Trading certificate program. Feel free to visit all the links that you find here in the slide deck. For those of you who might not have seen me in action personally, that's a picture where I give a talk on my private page. You'll find many things, but only very few that are really private or personal. Most of the things that you will discover there are centered around Python and finance as well, like links to YouTube videos or to slide decks or to gists or to GitHub repos or to podcasts that I've been part of. So also feel free to have a look here. All Python for finance, not that much about my personal interests, etc. The books that I've published, you see here, the best-selling one for sure, the one in the middle, which came out as a second edition just before Christmas last year. So there were almost exactly 4 years between the first edition and the second edition. So many things have changed and are still changing. So just in preparation for today's session, I checked, of course, the codes and the Jupyter notebooks that I want to demo. And I noticed that something in pandas again has changed. So I took the opportunity and updated DX Analytics in this regard. So I'm pretty happy that the ecosystem is still so vibrant, and now that we have so many financial institutions involved in the field, I think this will be, for a while the same way, maybe even becoming better. My new book is Artificial Intelligence in Finance, of course, a Python-based guide, and I promise that you will see an early version during this program. I've just finished, before I left for India, the 5th chapter of the book, so watch out. Soon we will put a first version, not of the whole book, but of what is available on PQP, so that you will be among the first to read and see what is in this new book. It's scheduled to be published early next year. We run communities as well, not only our online programs and around what we do with the platform, for example. We run real-world communities in London, here in New York, also in Europe, and in Berlin, Paris, Frankfurt, but these are the two biggest ones due to the fact that London, New York obviously are financial centers. So if you happen to live nearby, feel free to become a member and show up for one of the events that we run there. Even if you are not close by, you can become a member, and where you will receive updates and links, for example, to resources. Happy that I can list partners with which we are working since years, with all of them that you see here. Thomson Reuters, originally Refinitiv these days, also Fitch Learning, CKF Institute, and very important here for the program, the HTWSR, our German university, with which we cooperate in order to issue the university certificate. So a big thank you to the partners which are on our side since quite a few years already. So the program. Now let us dive into the program and what to expect. I start on a high level, so more or less Superman perspective. Then we dive deeper into the single elements. Over the years, it has been growing. So here, 16 weeks, this is what we got started with. In the beginning, I was a little bit more ambitious, but what we are now covering is, I think, at the limit, what makes sense over a 4-month program, many thousand lines of code. So here I have a number 5,000 plus. I'm pretty sure if you put everything together, it's more like in the range of 10,000, 15,000 lines of code that you will get. Also, the documentation is pretty comprehensive. Jupyter notebooks, videos, hours and hours on end that you can study. So our hope is that you get really like the comprehensive education, comprehensive training that will equip you for the challenges and requirements of today's financial environment. Of course, there are books there are the codes that we provide, the pre-recorded video instruction. So it's a wealth of information that you have access to in that sense. And I know it's challenging at times. So in today's orientation email, you might have found a few lines which are saying, well, in the beginning might be a little bit overwhelming, but focus on the big picture. And since we are repeating many important things a couple of times, so it might not be at the first go that you grasp everything that is presented, but at the end of the program also, in particular after the practice phase where you apply the single elements on your own, many people say, well, now it feels like second nature, and firing up a cloud instance, running a Docker container, this is really now second nature, and that's actually the goal. Not from the beginning, but after the program, you should be in a position to feel the same way. And why is it so important? These are slides that I present recently kind of regularly. So it's the big banks, it's the hedge funds, they all require these days coding skills. And it's usually targeted towards data science, what I call financial data science. I think my Python for Finance book, this is mostly financial data science, as we call it. And of course, I'm happy to see that the big institutions, basically since years, but now it has reached kind of like the press, so to say, use Python to this end, because Python has established itself as the go-to language for data science and machine learning and all these related topics. And I think our field, and I agree with this article, which is pretty recent from June 16, that there is this sweet spot of combining financial know-how, knowledge, experience, practice with like the technological skill. And this is what exactly I think describes our program, in the sense of that, of course, we do Python for finance in a general sense. In some areas, we go pretty deep in the financial field. In other areas, we go pretty deep on the technology side. But when you combine the two with each other, I think you indeed acquire a key skill that helps you to strive in today's financial environment. Here, a very recent article which relates, and this is the reason why I've included it as well here, also finance with the requirement to know these days more and more about AI in general. So AI and finance is our answer to these requirements. We cover since quite a while machine learning techniques in the PyAlgo part, for example, but there is more to come. There's more on the horizon, and we have leveled up what we provide in the program here, I think, to a significant extent. So our hope is that our comprehensive program with all the resources that we present equip you really for today's requirements, no matter whether you want to do some personally motivated algo trading program from a cloud instance that you personally set up, or whether you work for a big financial institution where you can use these skills, or whether you want to change maybe even a job and say, well, this is the key skill that I'm missing. Our hope is that the program will equip you pretty well, no matter what your goal is in our field. So let's get started with the topics themselves. I said this is just meant to provide an overview, of course, so that you get a feel for the structure, what to expect. Finance with Python is our intro class that we've come up with some 2+ years ago, because we have in the programs typically people with diverse backgrounds, meaning that some have more finance-oriented background, a little lesser maybe programming. Others come with a strong programming background on data science and say, well, finance seems to be a very exciting field. I want to enter that. So our approach here is to try in the first 2 weeks, in particular with finance with Python, to level the playing field and to bring, no matter where you're coming from, on the same level with regard to the basic financial notions that we consider important, to the very basic fundamental concepts of Python. This is not getting too deep there. So we call this a gentle introduction to finance, Python, and the combination of both. So we cover fundamental financial topics as an introductory part, because it provides a, from my point of view, perfect background to get started with Python as well. So modeling a simple financial economy, let's say for the purpose of some simple option pricing, allows us to make use of Python and NumPy, for example, in a simple setting, but nevertheless meaningful setting. And once you master this in simple settings, I think it's pretty straightforward then to level up and to say, now let's generalize this to more complex examples. And so far, we got respective feedback there, made us kind of happy. So that's the starting part. We typically have multiple resources related to a single class. So I showed this live on the Quant platform with a quick run through so that you exactly see where to find the single elements. So we have documentation in the form of HTML documentation. There are also PDFs available. We provide the videos. The videos come along with additional resources like Jupyter Notebooks. So Jupyter Notebooks can be executed on the Quant platform. You also have always the option to download Jupyter Notebooks, let's say, or other Python files to your local machine and execute them there. So this is all there, but I will show in a live demo exactly how this works. And once you see how it works for the single class, for the other classes, it will be the same thing. So there are some minor differences, but the basic approach will be the same. Tools and skills, very important topic, I think, these days, because with just standard Python programming, you can only get that far. I think the time has come to level up the tools and skills area as well. So here, one of my favorite quotes from Yamamoto Musashi, one of the most famous samurais who have ever lived, and I myself, some of you might know, doing martial arts since long. And here, what this famous samurai points out is that one should, every once in a while, sharpen the equipment that one carries around. So it's not only in martial arts that you should sharpen your equipment. I think this in particular holds true for programming. And I know for many there will be a steep learning curve with regard to maybe new tools, new technologies that you have never encountered. And again, I think it's just like to see what's possible and to play around with it. And when you see some fit and some benefit, then to stick to it. So it's not like that every single minute detail needs to be mastered from the beginning. This would be too nice. All the grandmasters, not only in chess, let's say in music as well, they usually train for years on end, and most of them for decades. So it's no surprise whenever you see somebody that has a high skill level, probably this particular person has put in many hours or even years of time to sharpen that particular skill. So that's the overview of the skills that we cover. So the basics are related to Python installations and environments. Here we distinguish into Mac and Linux on the one hand side and Windows on the other hand. This holds true also for Docker usage with Jupyter notebooks, also cloud usage, because there are sometimes minor differences, but they may be significant in the implementation. So once you know about the differences, exactly, it's like always in life, they might seem minor, but from experience, this is in the beginning very tricky. So we tried our best to make it as concise and clear as possible for the two major platform areas. So Mac and Linux, things are pretty much the same. But on Windows, for example, there are then differences. Therefore, the basics here are divided into the parts, and I'm pretty sure you can pick the right one for what you want to use on your own. Throughout, we cover certain selected Linux tools and shell basics. This doesn't go too deeply, but many Linux tools are simply beneficial to have available no matter what you do. And this is an ongoing topic, more or less. We also cover code editing with Vim. Many people say, well, Vim, this is like old age. But for example, when you work in the cloud, on a cloud instance, let's say for proper deployment of an algo strategy, it might come in handy that you know a little bit of Vim and are not messing around with some, I don't know, third-class web-based thing. So we see lots of benefit. I use Vim on every platform, let's start on Windows, on my MacBooks, in every Docker, on every cloud instance. So Vim is for me the go-to editor, for example. Although when I'm writing books, for example, I use locally Sublime, but I couldn't use Sublime in the cloud if I wanted to. Therefore, Vim comes in handy in all the places. Then we cover a lightweight tool chain for like session management and also debugging and logging. Doc tests, unit tests are a topic. Git version control, Python packaging, documentation, code hosting, down to a case study where we say, well, now let's combine all the things together. And again, probably not everything is equally relevant to everybody. But for example, if you, let's say, are working for a larger financial institution and there's the task of writing a Python package, which is to be shared with others, this might not need to happen on GitHub, on public GitHub. This can happen internally based on the same approaches that we cover based on public GitHub. So these tools and skills are indeed in many circumstances pretty helpful. So we cover basics of the cloud, Docker instances, Python interpreter, Jupyter, and I will have a quick demo for this as well. As before, resources, videos, codes, script, etc. to be found on the platform. So this holds true throughout for all the classes that you see here. Python for financial data science, that's also a core class. So my world, what we focus on is divided in three major parts beyond the basics, like let's say tools and skills that you can apply in every area. I see like the foundation in Python for financial data science. Then we have the specializations, if you like, in Python for algorithmic trading, as well as in Python for computational science, for computational finance. So these are the three major areas, and I think you see them reflected here in the program as well. Python for financial data science, here we cover over the course of the formal program these topics here. Again, basics are about data structures, in this case, NumPy, pandas, OOP. And when you have a look at my book, and you get also HTML version of the first 13 chapters on the Quant platform, this is one part, the part about the basics. This was restructured for the second edition in this case, where I have put together what I would consider for financial data science, the basics there. Then data science itself, visualization, interesting topic, because you see a little bit more than just like many rows of numbers. Financial time series, very important topic, plays a role basically no matter what you do in finance. Input output operations, also important when you deal with larger data sets that need to be read from disk or written to disk. This is where this topic comes in handy and provides you with a number of options that you can use. Then performance Python, I think in particular in finance, we have in many different areas, we have the requirement to come up with fast solutions and not only solutions that somehow work. And when I started using Python for finance, basically, well, more than 10 years ago, it was close to 15 years ago, people said, well, this will never work. Python is an interpreted language. Python is well too slow. If you want to do proper finance, you need to go to C, C++, etc. I think we have come a long way, and this chapter is, I think, support for the claim that Python can keep up performance-wise in many areas, not in every single maybe highly specialized area, but in many areas with other languages as well. And then the more math-oriented topics like mathematical tools, there's something like symbolic computing, differentiation, integration, let's say, stochastics, are pretty important for risk management, option pricing. So under the hood, let's say, Monte Carlo simulation that's going on there, then statistics and machine learning as well. And there is this one special topic which is also so important in many other areas. It's dates and times, because typically when you do some finance, sooner or later you will for sure have the requirement to deal with dates and times. So all topics that I would consider core for financial data science. I'm not saying that these are the only ones, but I consider them core, and they're a complete set of resources, videos, documentation, Jupyter notebooks, etc. And if you want to, of course, you can reference the book itself, the second edition, Python for Finance, or, for example, access it via an online service such as Safari Online, which I'm a big fan of, because Safari with a single subscription provides you access to hundreds, if not thousands, of interesting books for our field. Python for Excel, now we are entering what we typically call the optional topics beyond the core class. So far, I have shown you topics that we would consider at the core of the program itself, not the core classes. I come to the core classes, but now we're getting started with selected classes that might be of interest for the one or the other, but that I wouldn't consider a necessary prerequisite, let's say, to prepare the final project in Python for algorithmic trading. So this can all be done without Excel, but I know many people out there in our field use Excel extensively, and I think adding Python to the mix is a wonderful thing. So with the Excel Wings package, you get kind of like 3 levels how you can combine Python with Excel. The one is an interactive approach. The other one is that you call Python scripts from VBA. And the third, and from my point of view, most interesting part, but this is only working on Windows, not on Mac. These are user-defined functions, UDFs, where instead of writing something in VBA, you simply write a Python function. And by simply, I mean, indeed, simply, the Python function may be complex, but the integration into Excel and then calling this user-defined function, this works seamlessly from my experience, and it's a wonderful addition, I think, to the Excel world in this sense. Python for databases, same thing. For many, this might be an interesting topic. For others, they say, well, it's not my core topic. I'm more on the analytics side and visualization, maybe trading and deployment. But databases, of course, are something that is omnipresent in our field. And that's the reason why we have this class as well, for those who see fit for their requirements and here an introduction and motivation part. Then we dive into the SQL and NoSQL world with MySQL and SQLite, two of the most popular open source options that we have there. The MongoDB as a NoSQL, an object document store. That sense, PyTables is pretty powerful when you work primarily with numerical data, let's say coming from NumPy and array objects, or let's say pandas data frames. SQL Alchemy as an abstract layer, which allows you to add in the end different backends in the form of, let's say here 2 examples, MySQL, SQLite, and which allows you in the front end on a Python level to write Pythonic code, and the abstraction layer then takes care of the SQL that's happening in the middle between the object-oriented code on Python level and the database storage. Might be not as simple exactly as I was pointing it out now, but it's a powerful tool indeed for those who have fitting use cases. Because is a columnar data store, which is pretty fast with a tabular data, columnar data. So it's a nice addition, which is a little bit exotic maybe here, but dealing with time series data, large data sets, this might be a good addition. And we close this class with a comparison there of the different technologies, in particular also with regard to the performance given different data sets. Resources, the same here. We also provide like a bash script to install everything that's required in the cloud, because, for example, running a MySQL server locally might be a little bit involved. So where we can, we try to provide all the tools, all the scripts, all the code lines necessary to be as efficient as possible with the single requirements, technical requirements. And the databases, they have, it's like MongoDB and MySQL. This is not as simple as installing, let's say, a simple Python package. Natural language processing, also a recent addition, becoming more and more important in our field. So we recently have implemented 2 projects with Dow Jones, for example, where the focus is on NLP. The first project was on larger analysis and the relation between news and the impact on stock prices. For example, there is a published paper already out there. And the second one is about streaming processing of text-based news and other sources. So this can also be done in real time. The focus here in the NLP class is not on the real-time side, which requires a little bit more than what we cover there, but it's not like kind of a big leap to get to the streaming side then as well. So we have, as usual, the video-based resources, the codes, and here the code. I think the major benefit of that class is that we have compiled a larger package module file, which contains many helper files, which you can use out of the box, which took us quite a bit of time to come up with, but we provided here. You see, like, clean up HTML with like regular expressions, etc. So once you have these available, you can use them over and over. So there's no need to rewrite them and get started from scratch. So here we try to provide you with like the major tools and helper packages that we have come up with to scratch our own itch, so that you can use it out of the box and don't need to invest hours on end to replicate maybe what others have created for internal use, but have never published, let's say, on GitHub, so to say. That's the approach of this class. Then we have the AI in finance class, which I would consider a core class for PyAlgo, but optional for the computational finance part. But of course, it's open and feel free to explore this area as well. The focus, but I must say, is on the trading part there. And this is simply against the background of observations in terms of what traditional finance is all about. So this is in my new book. This is one chapter about normative finance. Then I explore data-driven finance and what this brings to the table where there might be problems, what machine learning brings to the table on the other hand, and when we combine the data-driven side with the machine learning side, what this might mean for future evolution of finance. And the trading side, from my point of view, is one which allows for easy illustrations and where the benefits, I think, are evident. So that's the reason why, among others, I focus on this part. So have a look at the class. I think pretty interesting topics. Also, when you wanted to understand maybe on a more fundamental level how let's say on a code level, fundamental code level, how deep neural networks work. This class, for example, develops deep neural network fitting and training approaches, classes with different approaches implemented from scratch. So it's not only that AI in finance uses out-of-the-box packages like Keras with TensorFlow or scikit-learn, to name the two packages that I use, but it really goes down to the machine room and shows how things are handled on a more fundamental code level. Python for algorithmic trading. Now we come to the core of the core classes there. That's the structure. We have the foundations, finance with Python, 1, 2, 3, 4. This is the same for computational finance as well. We then have financial data science, also the same for computational finance. And then from week 4, there's basically the separation into the core classes, because here we then get started with the strategies themselves. Financial data science is important for, I said it before, no matter what specialization you're after. Therefore, from that point on, you should have acquired the basic skill set, tools, and background information, background know-how, so that you can get started here, in particular with vectorized backtesting, formulating simple strategies, for example, based on typical technical indicators like simple moving averages. Then we move on towards more involved approaches like prediction-based trading using machine learning and deep learning algorithms. Then event-based backtesting is brought into the mix. Vectorized backtesting, basically it's my favorite because it's so simple and fast and easy to visualize, but it has its limits. So if you want to get closer to the markets and want to gain like a more realistic picture of how your strategy might perform, this is all really simulation, and somehow you need to come up with a little bit of trust in order to get started in the markets. But this might help in coming up with a more realistic picture. Indeed, it requires quite a bit more coding. So we just had a final project that was handed in, which only focused here on the event-based backtesting side and came up with things like take profit, trading stop loss approaches, etc. So pretty important topic as well, of course. Then the algo trading side itself, real-time data streaming, is a basic skill that needs to be acquired in order to then work with the likes of Wanda as a trading platform, FXCM, Interactive Brokers, or Gemini. These are the 4 trading platforms that we cover. So that you should be then in a position, this is then week 12, to combine all the elements together, or where we then cover on top of that automation and put the single pieces into their place and try to orchestrate it like a conductor. It's orchestra. And of course, this is always a good chance to review the single other elements, because at that point, when you want to get started with automation, this is indeed then the point where you say, well, do I have all the single elements together, yes or no? And then you might get back and do a little bit of a review in order to get it to a level which is required for the implementation. Then we have the practice modules 1 and 2 on strategy, deployment, and of course the final project research paper. So this is something that we typically communicate towards the end. We know this is also of interest to many. I sometimes get like just before we start like questions with regard to the final project. At this point, I would recommend that you lean back, quote unquote, with regard to the final project. We communicate the exact requirements later. Currently, the focus should be on acquiring the necessary know-how, tools, and skills so that you are in a pretty good position to prepare your final project, which is a prerequisite to earn the certificate. My thinking in terms of Python for algo trading is driven since years, I must say, by these 7 layers. So we cover infrastructure, financial data, the strategy code, the backtesting code, be it vectorized or event-based. Then we get to the real-time streaming world with the connecting code. The trading code needs to be implemented. What we backtest are what is called typically offline algorithms. So offline meaning that we have a complete data set available and we test the strategy on the data set. If you want to translate this to the real-time world, we need to come up with an online algorithmic version of what we have backtested, meaning that the algorithm now needs to be able to digest data in real time. And everything needs to be then automated, let's say like real-time monitoring, P&L monitoring, risk monitoring, and logging, debugging, and all these things that need to be put into practice in the automation part. So these are my 7 layers of my thinking with regard to Python for algo trading. Python for computational finance. I would say this is the financially most involved class because we cover there a couple of involved topics. Probably class itself, if you have never heard of certain topics, won't suffice to understand everything in every detail, at least on a theoretical level. On a practical, applied level, this is possible, I would say. But there's, of course, the book, Derivatives Analytics with Python, which provides many, many more details, among others, proofs and derivations of formulas, let's say, and of course also many references if you want to go even deeper. With that word of caution and warning, even here the overview. In the beginning, it's the same as I mentioned. Then we get started with a market-based valuation. This is like the intro class, which covers the whole process based on a simplified example. Then complete market models like Black-Scholes or the binomial option pricing model. Risk neutral valuation is then one of the core topics because it will be applied later on intensively. This is theoretically involved. We just scratch the surface here on the theory side, but Python is so wonderful like implementing these concepts. Therefore, the focus here on the applied side. Fourier pricing theory, also pretty involved, but in the Fourier pricing application part, we see that even without maybe having mastered the last minute details, this is kind of a pretty powerful approach that we can apply for many problems in option pricing, in particular for the calibration, fast and efficient calibration of more advanced models. American option pricing based on Monte Carlo simulation is here a major topic as well. General market model. This is a model that is from Bakshi Chao Cheng, end of the 90s. So it's not pretty new, but it's general enough, I think, for many equity derivatives oriented problems in the sense of that it encompasses the jump diffusion, the Heston stochastic volatility model, and the Bates stochastic volatility jump diffusion, and adds even to the mix a stochastic short rate model for discounting. So it's kind of like interesting, nice model that we then, once we have calibrated it, can simulate for American option pricing. So the further we go into topics here, so the more we can combine what we master there, like calibration, then hedging based on a calibrated model. Here we show examples in a simple Black-Scholes world, but also in more advanced topics. We will then have a review and, of course, also practice. Without practice, it's all hard to fully digest and master. So that's the, let's say, theoretical part, the Python programming part, and the whole class is based on derivatives analytics with Python, like the Python for financial data science class is completely based on the Python for finance book. Here you see like the codes that are provided there as well. Mostly they are used for class as well, but in updated version there. And in addition to all that, we have, of course, our DX Analytics package. And this was something that I did after I finished Derivatives Analytics with Python, where I said, well, that's all basically too involved. And I myself discovered that I'm doing stuff over and over. And I said, well, there's no kind of like pricing library out there implemented in Python that covers all the things that I would consider there important and which uses in a consistent way Monte Carlo simulation, etc. That's the reason why I came up with DX Analytics. Analytics has grown over time, and the core class in computational finance goes, so to say, in parallel through the theory plus Python plus everything what we cover in the theory in the Python side, then illustrated based on DX Analytics. So this is then where you get like the standardized and generalized version of everything that we cover, and basically much more, I can say, on the numerical side, much more than could have been covered in such a book of length, I don't know, close to 400 pages here. Quick start is what I show, like 2 minutes, or doing 2 minutes later, so that you get a feel for that. Framework, model simulation, European valuation, derivatives, portfolios. The focus here is indeed on portfolios. In the book, for example, portfolios are not covered at all of derivatives. Some involved topics there. Fourier pricing is there as well. American valuations, stochastic short rates. Again, portfolios, then adding these elements to the mix. Multi-risk derivatives, not covered in the book. Pretty involved technically, but with DX Analytics, I think easy to model. Implied vol and calibration, also on topic like on the theory side, hedging. And that's like the finale here, complex portfolios with, let's say, 100 different derivatives and maybe complex correlation structures, etc. This is what is illustrated here on the DX Analytics side. As I said, like just yesterday, I pushed some changes to the GitHub repo. So if you might have it installed, maybe you should upgrade it via pip upgrade there. It's some new stuff because due to the new pandas version, some things on the reporting side, risk report broke, so I needed to fix that. Complete documentation, of course, available on the web. So beyond what we cover, of course, feel free to dive deeper there and to make the best use for your specific use case. All open source, all on the web. So feel free to have a look at the resources, dxanalytics.com, or just Google DX Analytics. This should immediately bring you to the right place. Here, see the overview of DX Analytics, what this is all about. It's about the risk, neutral, present values, and creeks for instruments, positions, and portfolios of potentially complex derivatives. You see here Monte Carlo simulation of cash flows in a unified, consistent manner. Optimal exercise policies and risk neutral discounting is the backwards step there. We might have multiple risk factors. We might have European American derivatives, Bermudan exercise, of course, same as American in a discrete context. We can have single risk, multi-risk derivatives, positions composed of whatever. And then we have the portfolio, which indeed deals with the net payoffs. And we can, for the risk neutral discounting, because underlying this whole approach is the risk neutral pricing approach or martingale pricing, or fundamental theorem of asset pricing. There's so many different words that might mean the same thing. We can use constant discounting, like simply used in many models like Black-Scholes Merton or Heston's stochastic volatility model. We can also model a yield curve and do a deterministic discounting, or do even a stochastic discounting, which might be interesting for long-running equity derivatives. So that's basically the overview for DX Analytics and what it can achieve. And this is pretty much scalable, not for like a bank, which has overnight to do some risk calculation for 2 million positions, but going into the thousands with the proper infrastructure, I think DX Analytics is scalable. This is my pyramid for the computational finance. See, I like to think in layers and in pyramids. Infrastructure, financial data, same as before. We get started same way. Here we then have the models, then we do the simulation with Fourier pricing for the calibration, which we then implement, usually based on Fourier pricing. But with DX Analytics, for example, many examples I've implemented myself, you can also do the calibration of the models based on Monte Carlo simulation-based prices. So it's fast enough these days. Market-based valuation is our goal. And last but not least, we have the hedging topic. And on top of that, or around that, no matter how you want to put it, we then have not the single instruments only, we have then the portfolios and the higher levels of abstraction in this context. So these are all the elements. I see it's quite a bit to cover, and in particular quite a bit given the time frame that we have. And speaking of the time frame, and I'll show you the study plan. You have received a link to the study plan, and this will be updated usually once per week. There might be 2 updates per week, something specific happens. You see here some remarks, some guidelines, but the major part is the table that you see here, and of course it is hosted on the web. You have access to it. This is publicly accessible. So here we're now in the first week. I usually like a light blue background. We see what is important in the different areas. We have algo trading, comp finance. These are the core classes, the first 2 columns. Then we have the live sessions, financial data science, tools and skills, AI and finance. This goes from A to Z, so to say. And the optional classes, here like Python for Excel. We have OOP elements as well, which are optional. We have PyDB, the database class. You see the database alone has 6 sessions, and natural language processing. So it's quite a bit, and it's getting updated. And you get, in this respect, also, of course, the weekly orientation emails, which guide you at the beginning of the week in general through the different topics. So if you have questions in this regard, feel free. Usually it's best to post them in the user forum. So if you don't have organizational, personal questions, please think of the user forum. I will say a few words about that later on. But the user forum is something that you should always keep in mind whenever you have a question, organizational nature or technical nature or quant platform oriented or code oriented. All these are topics for the user forum because others will benefit as well. And you benefit also. Instead of writing me, for example, personally an email, if you put it in user forum, the chances that you get a quick answer are much, much higher because I'm sitting sometimes like 10 hours on the airplane and avoiding actually Wi-Fi access, I must confess. So others might answer a question much, much faster than I might be able. There's a question with regard maybe to the documentation of DX Analytics. There is, for DX Analytics itself, there is no PDF documentation available because we updated that regularly, and it's not written like a book, so to say, which you will read from A to Z. It's rather that you look for a topic, and then you might want to have a look at the documentation, or you directly go to the GitHub repo where you get the Jupyter notebooks, which show everything like live and executable. So, and this changes sometimes pretty fast and regularly. So for DX Analytics, there is not a PDF documentation available for that reason. So now the case studies and the demos. Please don't be shocked. Word of caution again, when I now go rather quickly through certain topics, I just want to show that many things that need to be learned or need to be mastered are not that complex with a little bit of training on the one hand. And on the other hand, I will go quickly through certain Jupyter notebooks that I selected deliberately and with specific purposes from the huge set that is available, just to show you a couple of things that I consider pretty interesting. So the case studies and demos are as follows. I want to get started on the quant platform, a quick run through what to find where. Then Python with Docker. I will show you that it's not really rocket science to get started with Docker and to put up a Python environment from scratch. Then I have a notebook which covers the topic of efficient markets, which is kind of like the major benchmark against which we are running in the Python for algo trading part. Model calibration is a core topic from the computational finance class, which makes basically use of the efficient market hypothesis, where we say, well, the prices that we observe in the markets are the proper ones. And this is what is used as the theoretical background, so to say, as the foundation for model calibration. Then I have a quick run through. Actually, it's called the Quick Start Notebook, through the package, not through the package itself, but showing you just a few things. Then a smaller, shorter Jupyter notebook about market prediction and what to expect there. And then I do a little live demo based on the Rwanda trading platform. So this should give you a good feel of what to expect in the single areas. And I want to get started with the quant platform. So everybody should have login to the quant platform, but not every login, not every quant platform starting page looks the same for everybody. So that's mine. You see on the left-hand side here, it says something like new notebook, and then there are a couple of folders, but it only shows in this area Jupyter Notebook. So not like a Python file or a text file or a PDF file. This won't be shown there. So this is just meant for navigation related to Jupyter Notebooks. Then you have the tools part, which is pretty important. So tools, file manager, task manager, editor, shell, user forum. And then you see in my account, I have edit trainings and edit course user. This is something you won't see. Under settings, you will see my account, but I have administration here, for example. So again, login, the basic structure the same, but some points here on the left-hand side navigation might differ. Then you see under trainings, the first three. So these are HTML documentations. So finance with Python, the first one, Python for finance and Python for algo trading. And I intentionally left it here in my account. Whenever you see something like update here, this doesn't mean that the text is updated, but that the codes that accompany this particular documentation have been updated. So once you click that, you get the latest version for the different documentations that you see there. Then we have the other classes, so quite a few you see here listed. You might not see as many as I have here. I have them all. AI and finance, finance with Python, financial data science, then the algo and computational finance certificate areas, tools and skills, Python and Excel, Python databases. Feel free to explore them all. Then we have the help part here. Platform, Python training brings you to our page, and there is one important link, the check port one. And sometimes people, for example, trying to follow along from, let's say, their office, they might sit behind a firewall, as we say in IT, and one port that needs to be open in order to make use of Jupyter Notebook on the platform is the port 8000. So whenever there's something happening or related to somebody who's not being able to run a Jupyter Notebook, to open a Jupyter Notebook, please make sure that you check the port connection. And if you see a red check, then everything is in order. If the port will be blocked, you would see a red cross. So whenever you see a cross, this most probably means that you're sitting behind a firewall, and that from at least this network, you won't be able to make full use of the platform. And before you ask, technically, we need at least one port to run Jupyter Notebook. So we can circumvent that because the standard port is used for the whole rest. So one port is required, it's 8000. And if you see the check, all is in order. If you see a cross, then you might need to speak to IT, use your mobile connection, or access to Jupyter Notebooks from back home. So now let me get started with the finance with Python part. So it's the first class because this is now on the agenda for the first week. When I click on finance with Python, it opens a tab there, and it shows then after a little while, this has become like the others, long documents. So I recommend usually that you open it and then maybe have a sip or two of coffee and wait until it is fully loaded, because there is one of the topics that slows it down are the many LaTeX formula that are in there, and all the LaTeX formula, they need to be rendered one by one. So this takes quite a bit of time. So whenever you wonder, oh, this is taking a bit of time, yeah, but you just need to load it once. So you see this has been updated January 2019. And you can scroll down or you can navigate. Of course, you can use the links here, or you can use the left-hand navigation, and I can here navigate to net present value. And you see here, this is still rendering. Sometimes the rendering takes a little while because the LaTeX render server, that's a service that we use, might be relatively slow. So as I said before, whenever you see the LaTeX code not full here, you see it fully rendered, right? That's the LaTeX formula that is rendered. but you should give it maybe a minute or 2 or 3, but I don't want you to wait that long. Now you see it's rendering on the fly. Something we can technically circumvent because it's Python for finance, and the finance part requires many formula, and I don't know, there are hundreds of formula, I would guess, here in this document, and therefore maybe you open it, wait 2, 3, 5 minutes depending on the machine, and then you can access it fully. So that's the documentation for that. So what you see here, and you will have also in your folder the codes. There is a folder here which is called FinPy on the left hand side, and you see here his FinPy 01, FinPy 02, or 3. So every chapter, there are 6 chapters. So here two-state economy is chapter 2. And when I click here on FinPy 02, it opens the respective Jupyter Notebook for this particular chapter. And the code that you will see in the Jupyter Notebook is actually the code that is used or has been used to write this chapter. So that's the very basis for the chapter of the documentation in finance with Python. So you don't need to copy and paste or rewrite it. If you want to jump right into the code, just go to your FinPy folder, watch out for the correct number here with regard to the chapter, and you can open it. So there is more, there are more resources. Of course, there are videos related here. So we have finance with Python videos. This is, you see here, this is the static documentation, and we have here the videos. When I open training finance with Python, you see that it opens the class itself. The videos are always listed on top, so you have direct access to the videos. You have also access to the videos one by one, and you should click here if you want to access the resources. Finance with Python 01, let's say. This was not my intention here. Now it has opened. You see that a module page opens, and on the module page you find sometimes quite a bit of text, sometimes just 2 lines here. It provides you also the link to the slide deck that has been used. The video is listed again, and you find additional resources. So the HTML documentation plus the Jupyter Notebook is not the only thing. You have also videos, maybe some slides, PDFs, and you see here attached files. So there is this lower part here where you see 3 more Jupyter Notebooks and also the PDF file attached. So I can double click on that as well. And as before, it opens from this module, it opens here in the Quant platform. So this has been executed, the other one hasn't been, and you see that every relevant resource can be accessed via the Quant platform, of course, for this class, and you can execute it there as well. So for the first 2 weeks, beyond a little bit of training with regard to the Python environment, you should have all resources there available, and in many cases also executable. So it's not only provision of the resources, you can execute most of the resources there as well. Not all the resources. So if you want to install your own Python environment, this is nothing that is supposed to be done on the Quant platform. This is something that you would do locally. But think of it, I close this now. Here, the blue headers are the links to the respective modules. So Finance with Python 3, you would click on that one and it shows you here the video, the link to another slide deck, and you also see here yet another Jupyter Notebook. So that's basically it. So let me close these elements. And now you know how this works, and this works basically for all the classes. We not always provide like HTML documentation for every class, not always provide maybe other resources, but that's the basic structure, and Finance with Python has in principle all the elements. In particular, it also has a PDF file, and now I want to show you how to access a PDF file. So here I click on File Manager, and in the same folder as on the left-hand side, therefore it's a good illustration, FinPy, Home FinPy, that you have, I can click here, double click on FinPy, and you see now in the file manager that there are not only Jupyter Notebooks, but there is also a PDF file. And when I double click on the PDF file, it opens here. it loads, and we have them password protected so that you can download and use them any place. And you have received the passwords with your login credentials. And when I provide the password, you see now there's the PDF page, and you can download it. You can use it on your iPad. You can use it on your local machine, whatever you're using. So January 2019, this is now the PDF version. This loads faster because this is all pre-rendered. So when I said the LaTeX rendering takes a while in HTML, this is due to the fact that this happens on the fly. But a PDF is simply a PDF, and the rendering has been implemented or has been accomplished already before. So you can read this on the Quant platform if you like, but I think most people would download it and use it locally, or let's say on a appropriate reader. So these are all the resources for FinPy, and once you navigate and play around a little bit with it, I think you will find it easy to do the same thing with the other classes as well. Then we have a task manager here. That's the next tool. And you see two things running, the task manager. The one thing is the Jupyter Notebook. There is no tab anymore, but on the left-hand side, you see here FinPy02. There it says shutdown. This indicates that it's still running. And the task manager says the same thing. So FinPy, and I can shut down it here as well. So when I click on shutdown, then the thing stops. I've opened a second one afterwards, and you see here the path to the one that is open, and I can shut down that Jupyter Notebook here as well. Now, no Jupyter Notebook is running anymore. You can also open the editor. It by default opens with a empty text, so I could here. So this is the intro and overview session. I can edit here regular text when you want to make some notes and write it down, save it as a text file. So here I can change the name, intro, let's say. But of course, I think the most popular use case is to use this to write some smaller Python scripts, let's say. Of course, it knows different syntax highlighting. You see here, oh my goodness, there's kind of a lengthy list for syntax highlighting, and among others, there's some Python. But it will notice when I would save this file with the .py ending, then it will provide the proper syntax highlighting. That's the editor. Then you have also shell access here. When I click on shell, for example, and now I can, for example, look up what is in my folder. This is now a proper full-fledged Linux shell. And you see here the file intro text, and I can, for example, have a look at intro text. Oh, it doesn't. I didn't save it, maybe, so it's probably still empty. Let me have a look via Vim. And when I open it, oh, you see, I haven't saved the text before, therefore the text file is empty, but Vim is available here as well. This is the intro session, and I can save it now with Vim. And when I now repeat my cat command, it shows me the content here. So it's a full-fledged environment. There is Git available, for example, if you want to do version control, and many other things that might be useful for the one or the other. So that's the shell. And when I close that one, the shell is still running. And now you see under terminals, it says terminal 1 is running, and I'm shutting now down the terminal. Then we have this very important link. This is the beginning, the most important one. Whenever you have a question, whenever you say, well, I have this, with a Quant platform, I have a question. Or organization-wise, study plan, certificate program. Here you have the respective board. Or finance with Python, or Python for financial data science. Python for algo trading is one of the more active ones. You can open that. There's a reason there have been questions with regard to the Python for databases class, third session, or here that one, interactive broker official API. And when I click on that, for example, you see there is a text. There might be some traceback. There you can also post some screenshot if you think this might help. So in the user forum, you have also syntax highlighting, and you see then I myself or somebody else might then answer questions. Feel free to make proper use of it and intensive use. Others, I can assure you, will be grateful when you make a use there. And also, this note, we get notified by email. So in the beginning, we often have it that people post something in the user forum. Then, let's say 5 minutes later, I get the respective email. We get notified by email anyway, so be assured we will receive it, but it might maybe take a little bit until we can get back to it. Yeah, that's about the platform. That's about how to make use of it. Of course, you see here, close it. Maybe one of the more important parts that I didn't show you, I haven't basically shown you maybe let's pick here the AI in finance one. You see here a bunch of videos at the beginning, also here like, again, the blue links. When you say, well, now AI in finance 09 is kind of like the video. Of course, you can play it here on the platform. So clicking on the video opens another tab and you have access to the video. You can have open, if you have, for example, multiple screens, you can have open multiple instances of the Quant platform. When you say, well, I want to see this a little bit larger, you can also here fold up the upper pane and the left pane so that you have basically full screen, or simply use the full screen option of the video player. So this is all possible, or you run, as I said before, like 2 instances of the Quant platform, left screen, right screen. Left screen might be a Jupyter Notebook where you follow along. Right screen might be the video that you are just watching. So it's all there. If you're missing something, just put it in the user forum, and I'm pretty sure you will get some quick help in this regard. So that was the quick run through, and I'm going to log out now. And I'm back at the beginning. So my first demo, and for you also quite a bit of a blueprint how to work with the resources on the Quant platform. So second is Python with Docker. This I will now keep concise and quick, actually, but just to show, because tools and skills I pointed out, we consider that important. Many of you might not have been working with Docker so far. This is just to show that we cover the basics, but with the basics you will get already to quite some decent level. Let me open here my shell. This now happens all on the shell, and I show it, among others, within Docker. To show you that Docker is no, should I say, threatening, magic, rocket science technology that is pretty difficult to master. Here I have already prepared my Docker run command. It's just like a few parameters that I pass. And the second main reason for using Docker is that I show you how to do all this from scratch, because on my MacBook, from which I'm doing today's session, I have, of course, Python installed, and I have fine-tuned it maybe over the years and here and there, but I want to show you how this works from scratch. Now I'm in a Ubuntu-based Docker container, which means it's like a Linux machine in the cloud. Maybe just like a basic frame, not too many tools are installed. So I would first do here a little bit of a housekeeping, receiving the current package index. Again, if you say, well, I've never seen this, you can lean back. This is covered in detail, documented, to get all the resources and hints in the class. So I've updated the package index. Now I do maybe some upgrade, so that I have the latest and greatest available. Maybe not the most comprehensive install I could think of, but at least a current version. And I might want to install one package that I need for what is to come. So now my Ubuntu world is up to date, let's say. What I want to use is wget. It says wget command not found. So what do? We install it, apt-get install. Again, you'll find all this in the respective class, apt-get install wget. Should I do it? We say yes. It's getting installed, and while this is getting installed, I look up the URL for Miniconda. You see here there's one page where you find all the installers for Miniconda: Windows, Mac, Linux, Python 3.7, Python 2.7. I want to have the 64-bit Bash installer in this case. There's no alternative. Python 3.7 for Linux. So I'm on Mac, but my Docker container is running Ubuntu. So I copy the link address, and I'm already finished with this page. Here, this is also finished. Now I have, let me check, wget is installed. Wonderful. So I can now, maybe I first navigate to root. Now I can say wget, paste in the link, and it will download the Miniconda installer. This is a package which will install let's say minimal frame for Python. So it has a Python interpreter. It comes with SQLite and a few more things. When I now have a look at my folder, it says Miniconda latest. Here's also a folder live, which I have mounted for my local machine. And now I say bash Miniconda, and it says, well, welcome to Miniconda. In order to proceed, we should read the license agreement. I press enter. Now the huge license agreement, which we read carefully, and I accept the license terms. Now it asks me where to install it, and the default installation is typically proper one. And it's now, you see, installing a couple of packages there. Now it asks me whether it should make Miniconda the proper Python version there, and I would say yes. I say yes. So, and thank you for installing Miniconda. We thank you. And when I now say Python, here it won't work. Command not found, because I need to activate it. So I simply restart bash. And now you see already, after I've typed in bash, you see there is a change in prompt. It says base, and I have now a base Python install. Let me check whether this is true. And indeed, Python 3.7.3, version 27th of March 2019, and we're good to go. So print hello Python. We are up and running, and I can exit the thing. Now I can get started with installing packages that I want to use. And again, this is a demo, not like instruction. I would say, for example, something like conda install IPython as my preferred command line tool, then maybe NumPy and no MKL to speed up things. Conda install, it's now communicating with the server. Should I do it? Yes, I agree. It's downloading a couple of packages. Shouldn't be that much. And we should be good to go. Let me give it a try. IPython 2. I started. This is now the much nicer Python prompt, interactive Python. I can now do import numpy as np. And now let's do the first thing. Random. Maybe draw some 50 random numbers and maybe some 50 more. So this was a matter of a few minutes. I started from scratch, did some housekeeping, then downloaded the Miniconda installer, ran it, checked whether Python is available, installed IPython and NumPy. I'm already good to go. So I exit. Let me just show one more thing. Jupyter Notebook, because it's such a powerful and often used tool. I install now Jupyter as well. So I say yes. The start command now might look a little bit involved, but this is due to the fact that I'm running here Ubuntu as root, and I need to provide a few adjustments. So from your local machine, it's typically much more easy. But given my demo, you will now see when I say Jupyter Notebook, I need to add a few things like port and IP. This is a larger package. You might have noticed 65 megs have been downloaded. executing my transaction, meaning it installs the packages. And what I meant is when I now simply say Jupyter Notebook, some of you might have done this already hundreds of times, it complains here about a couple of things. So I don't want to go into details, but the plain vanilla approach, that's the message, does not work for me. So among others, I need to do something like allow root. This is circumventing certain security measures. Then the IP address should be all local ones. Then the port, the one that I've chosen for my container, is 9999. And maybe also no browser. So with these parameterizations, you see, it doesn't complain anymore. It rather gives me now the URL that I need here. That's the URL with the token. It's also a security measure because I don't provide a password. And I can use this token now and paste it here in. And I'm in my container. So here, Miniconda 3 that I've installed. It's a little bit small of a font. Miniconda 3, Miniconda latest, live. So this is like the mounted volume. This is from my local machine. And now I could, for example, click on something like that, and it provides me with editing capabilities. That's now a full-fledged Jupyter Notebook, and it took only a few minutes to get this up and running, just for illustration. Getting back to the shell, here Jupyter Notebook is still running, and this could now run for like quite a long time, as long as I'm not stopping the process, which I'm now going to do, and still running the container. But I want to leave this now, exit. Now I'm out of the container, and my container is now to be seen here. And you see, well, there's kind of a little bit. And Docker system df I can use, for example. You see here the images, Ubuntu, just like a quick look, Ubuntu itself, just like 64 megs, but the one container which is stopped actually has 1.4 gigs. So my Python installation comes with quite a bit of stuff. So you should be careful with Docker containers. If you don't delete them, they can easily present a volume topic depending on your machine. So I would now do Docker remove my, I don't need to, it's 242, and I have deleted now this container because I won't use this anymore afterwards. That's the little quick run through the Docker and Python installation. Well, these are topics that are covered in detail in the tools and skills part. So now efficient markets. Again, time doesn't allow to go into details. This is interesting topic, so it would basically be good to be able to spend a bit more, but this time hopefully we'll be there when we cover this in the class. And this is a topic out of AI in finance. And again, I won't say that much. I simply click through this Jupyter Notebook. You see here a bunch of imports. Then in this part, for example, we cover linear regression on a basic level. So with some simple examples, with some dummy data, introducing topics like R squared and how to apply this. Then we do monomial regression with scikit-learn. And see that, of course, the higher our polynomial that were the monomials that we use, the better the fit, because I got started with a cubic formula, so I need some cubic approximation to get some good results there. We see R squares, of course, improving on such a simple level. Topics like model validation are pretty good to introduce and visualize. So you see here, for example, when I train my model on just the first part here, and in finance, we so easily tap into this trap. Although for such a simple example, we all would say, oh, well, this is not like, I would never do that. But in finance, it's sometimes so subtle. Actually, here you see I train it on the first half or first 2/3, let's say, of the data points. And when I do some generalization, some prediction, you see this has nothing to do with what's happening there, right? So we might need different approaches. And from machine learning, random splits are kind of popular. So we would do some randomization and not take the first 60%, then the second 40%. We rather would sample 50% for training and 50% for prediction or some other distribution there. And when we do that, it's not a perfect fit, but you see, since we have trained it on like sample data from the whole data set, yeah, we have kind of a good overall fit, at least much better. Then topics such as validation curves are covered in a sense of how my model performs on the training data set, how the model performs on the validation data set, all important issues. And what we would like to have, here we see already something like overfitting. We would like to have the validation score pretty close to the training score and not something, of course, we don't want to have something like that here, that's for sure, but we also don't want to have something where the training score increases and the validation score drops. So if these topics don't mean anything to you, be assured they are covered in detail in the respective class. And then the efficient markets. So now, what about efficient markets? It is something that we are against or up against, and maybe here I just focus on this particular quote here. A market is efficient with respect to an information set as if it is impossible to make economic profits by trading on the basis of information set S. So this means that things like technical analysis of historical price data, of formation, of all like trend support lines, whatnot, should not bring anything. So in a least square sense, this is the quote down here, in such a case, the best predictor for tomorrow's stock price in a least square sense is today's stock price. So this implies, if we are serious about trying to predict the market, that we should better save our energy and effort and do something else. But of course, you see the major work here, the major ideas have been developed in the 60s and the 70s, but we might ask today whether AI in general, and machine deep learning in particular, might bring something to the table that might change the picture. But first, some support for the efficient market hypothesis, given the basic instrument of econometrics, financial econometrics, namely ordinarily scarce regression, what we have seen in Excel already. So I'm working here with the data set. This is a standard data set that is used throughout. I calculate like log returns. Here you see what they look like. And for many visualizations, I like to use cufflinks because it provides me with some nice interactive plotting here. You see Hoover effect, and not only Hoover, this is not the normalized time series, there's Apple data, Microsoft, there's also gold quote and euro yes dollar, the S&P 500, the VIX index. I can also zoom in, and this is much more flexible than matplotlib, static plotting, let's say, but it also comes at a computational and memory cost. I can plot the returns as histograms. You see the plotting takes a bit, but I get now the log returns, histograms for all my instruments. There are 12 instruments in there, or I can visualize the correlation matrix as a heat map. So nice visualization with nice Hoover effects, and basically it's just like a method call on a data frame. So pretty interesting. Thanks to Jorge Santos, a friend of mine, that he came up with this fantastic library there. Now, for the analysis, we work with lagged price data. Details, again, over and over discussed. I must say, this is one of the core topics there, details discussed in the class. And we have lagged data now, which we use and try, based on OLS regression, to predict future data. Think in terms of technical analysis, head and shoulders, or whatever jumps to mind in terms of price formation. We have a look at the most recent 7 days, let's say, and try whether we can use ordinarily scarce regression to predict the next day's price. And we do it here like automated for all instruments. And we see now the regression parameters for the 7 lags. And already at first inspection, we see, oh, the most recent lag has basically all the weight. And when we do some further analysis, we see here the mean values, And when I put it into a data frame, I can visualize that. And this says it all, basically. Much better, maybe, than the numbers that we have seen. Only lag 1, this is the most recent data point, price point, has here significant weight, like 1. And this is now the visual representation of the conclusion that if the efficient market hypothesis holds true, then today's stock price, or whatever financial instrument we consider, is the best predictor for tomorrow's stock price, or whatever we consider. And this is now for all the 12 instruments, and it holds across asset classes, even for the WIX, for the volatility index, which is, I would say, the most exotic asset that we have here. But when we then take the average, I think we are pretty close to like the word where we say all weight 100% almost on the most recent lag, and all the other lags have basically on average a weight of pretty much close to 0. That's the efficient market hypothesis visualized here instrument-wise, given our data set of 12 instruments, and here is the average data set that we see. So in AI, in finance, in algo trading, we are up against the efficient market hypothesis, and we should have a careful look before we get started. Now, many things can be argued, well, better algorithms than OLS regression. Or we would say, well, end of day data. Yeah, end of day, there's no money to be made. Intraday. All agreed, all is covered in detail. So the next one, calibration. And calibration makes actually use of efficient markets. Calibration says, well, I'm not like back in the 70s, as Black Scholes said. They said, well, we have a couple of parameters, such as the stock price and time to maturity, the strike price, the volatility, and the interest rate, that maybe dividends, depending on the instrument, that influence the price of a European stock option. And if we know the parameter values, given our formula, we can come up with a price. So basically, in today's world, we have many, many option quotes simply that we can read from data sources, Bloomberg, Refinitiv Icon, or from exchanges. And if the market is always right, if the markets are efficient, then we should use these prices and calibrate our model. So we put the whole procedure of option pricing upside down. And what is used here is the Merton 76 jump diffusion model, and we integrate here the characteristic function based on 3 different ones. Then we come up here with a simple numerical example. That's all good. So this is just to illustrate how it works. And now we do the calibration based on root mean squared error. So lots of formulas that are translated, and Python makes it kind of straightforward to translate your financial formulas to Python code, Python functions. Here I'm working with a Eurostoxx 50 option data set. I'm importing the option data set. That's basically it, the relevant for us. I'm now focusing on the call side. Could have focused on the put side as well. Here I'm implementing my error function, root mean squared error, and then I get started with the calibration. So this is now calibrating basically hundreds of option prices. So we've calibrated 100 or 100 runs, and per run we calibrate them. So it's not, when you see 100, it's simply like 100 iterations, but 100 times the number of option prices. So we do quite a bit of option pricing here, right? So therefore, Fourier pricing, because it speeds up things. You see the root mean squared error, how it decreases. The further we go, the better we get. We see like the current leading or lowest value on the farthest left. And when the global optimization is finished, this is simple brute force. So simply trying a fixed set of combinations, of parameter combinations for the calibration. And when this is finished, then the local optimization takes place. It starts with the best result from the global optimization and then applies more logic to it based on local minimization procedures using gradient descent, for example. And to see the local minimizer here is able to further improve, and it finishes after a certain while when there is no further improvement to be seen, and we see after the global optimization, this is the best value we could achieve. After the local one, we had an improvement of some 0.2 points more. And when we want to now visualize all this is already the finish line, where we see, well, given the calibration, we have the blue line here representing the market prices, and the model prices are represented here by the thick dots. And in the lower panel, we see the differences. So the calibration is not perfect. This is something we would never expect in a meaningful example from a parameterizable model, parsimonious model. But I think the fit is okay here. If it's okay enough, this needs to be decided in practice. But here the fit, I think, overall is good. We also don't have a bias, so sometimes the model is a little bit too low in price, sometimes a little bit too high in price. So first inspection, I would say this looks kind of nice. That's a core topic, of course, of the computational finance part, where we do similar stuff with DX analytics as well. Now, just to check back, efficient markets, model calibration, DX analytics package. That's the next one. So here my next Jupyter Notebook. This is the quick start Jupyter Notebook from the documentation. And of course here, this is the most important import for this very example, import DX. And after I've done the imports, first risk factor modeling with a constant short rate, so simple example. Then we go and define a geometric Brownian motion, initial value, volatility, a final date, frequency for the simulation, currency, number of paths, and here is the definition for the geometric Brownian motion, means the Black-Scholes model. When I do some simulation here, I can easily visualize, let's say, 10 simulated paths given my input parameters. The second risk factor is also geometric Brownian motion with a little bit more volatility. You see here now the path, 10 selected paths for the second factor. Then evaluation model, the first option to be valued is an American put option. So that's the definition of that. And you see here, once I have my pricing object, pricing and Creek's calculation is as straightforward, maybe even a little bit more straightforward in this context than with the Black-Scholes formula. So for the American put option, I can call present value and I get the present value. I get the delta, the gamma, the vega, the theta, and the rho. Of course, these are numerical estimates. All is based on Monte Carlo simulation. All is based on numerical approximation. So when I say maybe, or as convenient, or maybe a little bit more convenient than the Black-Scholes world, might be true, but it's by no means as exact as in the Black-Scholes world, because there is, for example, no closed formula for gamma or vega available for American options. There's not even a closed formula available for in general for American options as compared to the European ones. So convenience, yes, but we always need to be careful with the numbers themselves there. So European single, now we are back in the world, which can be attacked in general analytically as well with the European one, and it behaves in the same way. We have also added a few not really exotic other model like the Sabre Stockwell stochastic volatility model, also just for illustration. If you have a use case for that, feel free to read carefully documentation. But I think where the strength of DX Analytics lies is in the modeling of portfolios. And here I'm now adding constants for my two models. I have two models which are both geometric Brownian motion. And here I come up with a derivatives position for the put. That's a numerical single risk derivative. Then I have the call option, which is a European single risk derivative. And then I define here the risk factors and the correlations as dictionaries, the positions also as dictionaries. Then the valuation environment, which generalizes the parameters for the valuation. And last but not least, the derivatives portfolio. And now I have put them together for a unified, as some people call it, global valuation. I can now get the values for the portfolio, for the single position, as well as for the position. We see here the option type, the risk factors, etc. I can also get some more statistics, like the position delta and the position vega. I could also add this up for the portfolio delta, let's say, or for single ones. What is also interesting here is that we can calculate risk reports or generate risk reports. We can here for the delta, for example, it does something like a what if analysis or like disturbing certain factors. And we get some overview, which looks like here, where we say, well, the factor, if, for example, this is how this is to be read, when the first risk factor would have a value of 20% lower today than originally, then the value of the portfolio would be 122. And the same number here for GBM. We can also calculate net values. I think this is maybe easier to read when we say for the first risk factor, if it's at 100%, there is no delta, there's no price impact because it's exactly what we just did. But if the price of the first risk factor drops by 10%, then the portfolio value increases by 13, or if it rises by 10%, the portfolio value decreases to 10. So this is like a typical what if or scenario analysis. The same can be done, for example, for Vega here in this case. So when we change the volatility parameters, which are, of course, most important ones here in this context, we get the same analysis here. So this is the benchmark value 0, and then we see like when the volatility is changed by 5%, not by 5 percentage points. So if it's like volatility is 50.5, so to say, and we decrease it by 10%, this will be 5 volatility points. So this is how this is to be read. So that's about DX analytics, which goes hand in hand with the computational finance part. I did some changes. Maybe I saved the changes and close it. Then market prediction. Now PyAlgo. Beyond computational finance and pricing, which to a large extent relies, and it's a huge success story from my point of view, on arbitrage pricing, which in and of itself has the efficient market hypothesis and the dogma that the market is always right built in by default. We now turn to algo trading, which takes the opposite stand, which says, well, we are not accepting the EMH. We try to overcome this particular hurdle and try to beat the markets by whatever means. So this is then the next question to be addressed. And here I'm showing a pretty simplistic example, but it lends itself pretty well because it can be shown in a rather efficient way. So here I'm working with a Nuanda data set, which retrieves the data here from one of my servers. And see, this is from 1st of January 2018, and it goes until final trading day of the first quarter 2019. So 15,000 data points, open, high, low, close, volume as well. Volume is tick volume for Wanda. And here I'm now working with a bunch of features like SMA-based features, momentum-based features, volatility ones, also typical technical indicators like the difference between high and low and stuff like that. So with these features, I have my data set. I do now a split for the training and the validation. I have, after the next cell, I have a training data set, a validation data set, and my test data set. I work with 10 lags, do some normalization here, and I lag the data and normalize it. So this looks like lots of code, but it's explained in detail as well in the trading, PyAlgo trading part, as well as in the AI in finance part. So normalize and lag, length of columns. You see my my features are working now with 210 feature columns. And what I'm using here is a deep neural network, the MLP classifier of scikit-learn. So I have two hidden layers, 256 units each, and I'm training the model. This might take a bit, but not too long, as you can see, even for these like 15,000 data points, 210 columns. The net here is trained in 2.7 seconds on my local machine, so I'm working locally. The vectorized backtesting now takes the trained model and applies the prediction on the test data set and comes up with some positionings. Let's say a long position when the algorithm thinks that there is an upwards movement, and a short position -1 when the algorithm thinks that given the feature values there will be a downwards movement. This is all a game of probabilities, so usually not a sure thing, might be 51%, 49, but mostly it's 50.05 and 49.95. But we get like clear-cut predictions, up or down. And this is what we use here. And the model itself on the test data here, this particular constellation outperforms by 8 percentage points. No leverage whatsoever, no transaction costs. Everything is here on a very simple level. Speaking on transaction costs, there are 566 trades that take place, not too many for 15,000 data points. And when we have a look at the, oh, sorry, not 15,000, sorry, 15,000 was the original data set size. Here it's of course just a subset. Here it's of course just a test data set, and the test data set has some 6,000 some points. And when we visualize the performance over time, we see here no transaction costs involved, etc. The algorithm is mostly short, 5,803 intervals, bars, and 330 times long. And the blue line is the performance of the base instrument of Euro US dollar, and the green line is the outperformance. This is, of course, something we would like to see. In particular, we would like to see something after like that after transaction costs, but there is no guarantee. A, that you see such an outperformance, even with the most sophisticated deep learning model. B, that after transaction costs, it will still be profitable. Sometimes for like 6,000 data points, depending on the strategy parameters and the algorithm that you choose, you might see some, I don't know, let's say 3,000 trades. So transaction costs can easily eat up any promising strategy there. So that's the market prediction part. Again, this is the opposite stand to the typical financial theory approach in computational finance, where we say, well, if the market is always right, let's use the market prices, calibrate the models, and work with the market, and take the market as like our law and framework. Here we say, well, we observe the market, we want to learn from the market, and maybe we can beat the market to some extent at least. Opposite idea. And when we want to implement our ideas here, what we then need to do is we need to have access to a trading platform. So this is my final demo here on the trading platform. Wanda technology-wise, I think I must say I confess I'm a fan of the Wanda platform, particularly due to the API what they provide. I know many people coming to the PyAlgo site say, well, I want to do stock trading, I want to do options trading. Then Wanda is for sure not the right place because they don't provide single name stocks, they don't provide options, for example, but they provide a larger set of CFDs and currency pairs, which allow you to do some global macro approach. And I like to say, and this is a strong recommendation, technology first and algo trading and asset class second. In particular, when we talk about the retail algo trading world, where I would put ourselves in as well, because here we have an easy time trading, let's say FX, keep it as simple as possible, like the prediction from before. To trade bi-directional, we can go as easy short as we can go long. Capital requirements are low. And now I come to the major point why I'm a fan of Wanda is due to the API. They simply have, from my point of view, currently one of the best technologies out there. So having said that, I know we have many options. That's the reason why we cover 4 platforms. I'm a fan basically of all of them because there are many more than 4 out there. So the reason why we have chosen these 4 already indicates that we are a fan of them all. But to get started, go the first steps. One that has proven to be pretty useful. So here we work with one of our own packages, TPQ-OA. A few imports. You need an account, at least a paper trading account. What I'm now going to show is all possible with a paper trading account. So learning, training, implementing, all can be done in the beginning with a paper trading account there. Even if you later on don't plan to do a proper account, it's a good way to get started. What I'm retrieving here is for Euro, US dollar, for one of the instruments that they provide. I think they have a universe of 128 instruments. We retrieve data via the API here for Euro US dollar for a certain 1 day here, minute bars, 1 minute bars. We receive small data set and I implement a momentum trading strategy. We have seen this approach already before with a little bit more sophisticated strategy. Simple momentum approach, just like the average of 6 return intervals, and we say, well, if we have like a positive momentum, we want to go long. If we have a negative momentum, we want to go short. Mean reversion would argue the other way around. Here we go with the momentum that we measure. The hit ratio of my strategy for this 1 day, you see here falses and trues. So this is what we typically of interest. The hit ratio, we have more falses than we have trues. So here the hit ratio is just 47%. But this is only one side of the coin, and that's one of the reasons why I have come up with this example, because it shows that the hit ratio, where so many people are looking at, it's indeed just one side of the coin. You need to get the right movements right, not just like the majority of them. If you get the 10 biggest upwards movements correct and the 10 biggest downwards movements, as we all know, then you can become rich kind of easily. If you just get like the minute directional movements correct, well, might be nice number, but not make you any profit at all. So here now the performance of the strategy is not 8 percentage point outperformance, but here it's 1% for 1 day. And you see here the outperformance. You can argue whether this is a good one or bad one. That's not my point. It's a technical illustration here, but at least with a 47% hit ratio, I can outperform the underlying without transaction costs by 1.2% on a single day, actually. But we have the issue that we would have 259 trades per day, and easily this would eat up any kind of advantage. So we see here now like a single excerpt where see like the long short positions here visualized. So many trades take place here. Speaking of placing trades, maybe have a quick look at the application. I hope I'm in my demo account here. So this is one way of doing maybe day trading. Yeah, it's my demo account, has like a realized P&L of minus 121,000. There are no open trades, not a single one in my paper trading account. And here now placing trades, when I say API, create order, Euro US dollar 100 units, and I execute that, I get back here this JSON file, which gives me all the details for the filled order, execution price, etc. And when I now have a look, let's see here, have a look, there is now the long position. So that's actually where we are. We have the ticket numbers also under activity. I see things there, right? So I can now inspect here in the application orders, trades that have taken place. Although I've initiated here the trade from the command line, from Jupyter Notebook, and when I now want to close the position, I simply sell 100 units, so the units is minus 100. I get back my JSON object, and you see the position has vanished in my paper trading account. The transaction ID, let me quickly have a look at the transaction ID to show you the 3750. So when I put in here 37100, I can now look up the most recent transactions, and you see here 3749. These have been my 100 placements before. I did it with larger numbers, as you can see. So these were the last one that I just did here, 2nd of September. Then when we can place orders, when we have back tested our strategy and are convinced, then we need to get into the streaming arena. So here in the application, I have it here, on 5 seconds. This is the highest granularity. You can't get lower, so ticks are not displayed. But of course, you get, via such a trading application, you get real-time updates for the candles, for example. But I can stream data on the API level as well, of course. So depending on the time of the day and how much is going on, this might go pretty quick or might take a bit. This seems to me kind of slow, given the time we have in Europe. Now you see a few more ticks. And I have set here a stop of 5. So once it has reached 5 new quotes for the Euro-US dollar exchange rate, so bid and ask, then it will stop the streaming. Of course, for a trading application, you would maybe start at a certain time or given a certain event. You would process the data, you would generate your signals, you would place your orders, you would close positions, and maybe when time has come or a certain event takes place, then you would close out the algorithm. This is what we try to absolutely standardize based on the AI machine. Maybe there is something running. Test purpose, I told you the team is currently working. I might quickly log in, and there is a strategy is running here. So I can show you how the real-time monitoring looks like. It's now loading the data and all the tick data, and what is happening here see is reported in real time. We have these Hoover effects where we can inspect what's going on. It has opened a short position there. There's a long signal, and here you see the latest level there and how it performs, real-time P&L, also with the data presented there. This is basically what I've shown you: strategy, formulation, strategy backtesting, and here the deployment of such a strategy in real time. This is what the AI machine is about. But that's topic for another day. So here I'm going to close that out because this finishes up now my demos, which was the core part. So I said it before, just to give you an illustration and a rough overview of what to expect and the types of topics that we're going to cover, and hopefully to whet your appetite for the upcoming classes and different ones. So for every cohort, for every round of certificate program, I try to focus on particular topics. And one of the core topics that I want to focus on are, because many people have asked us, are exercises and smaller test projects. So what we have already are review questions, which cover for computational finance and Python for algorithmic trading, like all the classes, not the optional ones, but what we consider at the core, based on review questions. And we want to add to that review exercises where you have the opportunity to repeat what we have been doing. And then we have transfer exercises, which are meant to redo something, and test projects where you should do something new. So example solutions will be presented during live sessions. So you will get like Jupyter Notebook, which has just like the exercises and the little test projects. And then in a live session, sometime afterwards, we will present the solutions and will explain the solutions. Sometimes it might be a little bit more involved, sometimes a little bit more easy. But in any case, you will get access to all the resources. And in the meantime, a related question has been whether the demo notebooks will be available. And yes, they are. They will be available. Basically, I've told you that they have been taken from the classes as well. But when I upload the recording of today's session to the Quant platform, which you will then find in the live session parts. This might take one day due to the time difference a little bit, but then everything will be uploaded. We will provide a link to a gist with all the notebooks. But this is just like for convenience, because again, nothing special, quote unquote, has been presented, because the notebooks that I've shown have been taken out of the classes as well. So sooner or later, you will encounter these notebooks anyways. But here, the notebooks that you get here, like with regard to the review and transfer exercises and the test projects, they are like empty, quote unquote. They just formulate what to do, and we will present the solutions then a bit later on. So we might cluster a couple of topics and put priority more on one topic or more on the other one. So just wait out. We sent this over in time. You need to first get started and then review, transfer, and a little bit of testing as well. The user forum I've shown already. Feel free to post any topics, content related, technical, platform, whatever. But do me a great favor and everybody else, and in particular, not for myself, not for anybody else, for you yourself, read carefully through this post, how to create a minimal, complete, and verifiable example. I know in the beginning it's hard to get through all the material, and sometimes it's so easy to feel overwhelmed. But when you post a technical question and you expect kind of like a proper, to-the-point answer and solution, then this is kind of like pretty important to understand how to create a minimal, complete, and verifiable example. Sometimes we have posts that say something like, in the, I don't know, AI in finance session number 3, there is code presented. I cannot execute that code. Can you help? This is well too general. How can we, there can be a gazillion of reasons. So to create a minimal, complete, and verifiable examples along the guidelines presented here on Stack Overflow, and they have millions and millions of problems encountered over the years, this is what helps you to get to the core of the problem and allows us, when you have reached the core, either many people say, oh, Eve, thanks for like this link. I've read through the guidelines. I've come up with a minimal example and it resolved all my problems. I was able to help myself. But if this is not the case, feel free to post your minimal, verifiable, complete example, and we help as quickly and as good as possible. Importance of practice. So what we do here is not something like going to the movies, enjoying the movie, eating a little bit of popcorn, and going back home and be amazed and maybe excited. So this is indeed a practical discipline, and it's rather to be compared to learning to swim than to read like a novel, a thriller, let's say. Because programming is in and of itself a skill. My view of a developer is pretty close to the view of Lang Lang, one of the most popular and best piano players the last 3 decades, I think. And I read his autobiography, and he has not put in 1 decade, but up until today, I don't know exactly his age, but probably 4 decades of hard work and training. So we have a skill here. Whenever you see something doing some coding, maybe at a conference or in a YouTube video, probably there's lots of practice behind it. And here I like to cite Anders Ericsson, so the authority on peak performance. And I really like this book and I can only recommend it. Peak Secrets from the New Science of Expertise. When you look at how people are trained in the professional business world, you find a tendency to focus on knowledge at the expense of skills. I believe the best approach will be to develop skills-based training programs. And this is what we try here, to teach skills indeed. Training should focus on doing rather than on knowing. Of course, first, even the best piano player in the world has had a teacher, and the teacher has demonstrated how to play a certain piece of music, for sure. And this is what we do. These are the videos, these are the resources, but there is the point where you need to get wet if you want to learn how to swim, or where you need to get into the car and on the street when you want to learn how to drive a car. And it's hard sometimes. There are like steep learning curves maybe, and lots of sweat and more involved, but be assured, and this is kind of like something that calms me down that when I read this over and over, no matter which area you study, music, dance, sports, competitive games, anything else with objective measures of performance, you find that the top performers have devoted a tremendous amount of time to developing their abilities. There is nothing like innate skill or talent where people come to the world and they discover like something that they like and suddenly they are masters in their field. Even the most talented ones, if there is something like that, need to put in the time. And here is a quote that I like and that I like to use as a quote. Is from Elvis, our student in the beginning, and where we're still fine-tuning many of the elements and give it a feedback over the years. I mentioned it during the introduction. We have tried to improve all the areas of the program as much as we could. But he wrote, like, I like watching your videos, but it's much more interesting and educational to actually build something on my own. That's the practical part. Even when I bumped into issues, I was able fairly quickly find a solution which is a testament to the quality of the available documentation for the technologies that we are using. So enjoy, for sure, watching the videos and following along in Jupyter Notebook, but it's more interesting, believe me, to jump into the swimming pool than maybe to read a book about swimming. Having said that, for me, it remains to close up today's intro and overview session. You should now be equipped and ready to get started with all the resources that you find. Don't try to overachieve, let me put it that way. Get started easily with fun. Try to explore the concepts, the tools, the technologies, and the approaches. And I think that's the best way to get the best results towards the very end. We are there to help. Feel free to use the user forum for organization questions, to reach out directly, and watch out for more input from our end to follow. Have a perfect start, and I'm looking forward for some exciting and interesting weeks ahead of us. All the best. See you soon.